So now we will discuss about few more methods that we have implemented in the linked list, like insert at particular position. So for example, we already have inserted this many record 56, 30 and 70. And if you remember, this was the diagram that we tried. So now we are trying to insert at second position 51, in the sense after B we want to insert one more node after B before C. Okay, so this is what the second position is, and the value is 51. So let's see how it will work. So we can run this, we will execute in debug mode, and then we can see here, so position is 2, data is 51. Now we are checking if position is less than 1. Of course condition is 2, so 2 is less than 1, condition will be false. Then position equal to 1, again condition will be false because we don't have position equal to 1. So now what we are doing, this we always will be creating one temporary variable to traverse. Okay, so here we will have one temp, and which will also have the same address which is present inside the head. So in this, again a temp reference variable will be created, and they will have the same value which is present inside the head, which is nothing but, you can see, 2000. Okay, so 2000 will be here, and if I draw the diagram, so temp will also start pointing to B. We will try to find out the position which is best, which is which has been asked here. Like currently we will insert at second position. Now, while position minus minus is not equal to 0, okay, this is a decrement operator. So is not, and temp is not equal to null. So currently position value is 2, okay, and temp is not equal to null. Both are true because temp, if you see, is pointing to B object. So it will come inside this, and since we executed minus minus, hence the value of position will be 1 only. So this time 1 is equal to 1, condition will be true. So now you know it will create one object of node. So this one, if I show you the same, like node object will be created with the value of data that we pass here 51, and the next will be null. So we can draw one object anywhere. Basically, node can be created anywhere in the entire memory of our local machine. Okay, but definitely when they will create, that time they will have some memory address. So data will be 51, and their next will be null. Let's assume it has memory address 5000, and then when object gets created, their reference, it will return the address that will store inside the node. So we will have one temporary variable, node is equal to 5000, which will be holding the address. Let's name it e object, maybe. Okay, any name we can give. Then what we are doing, temp dot next. So whatever the value present in the next, which next, the object which is pointed by temp. So temp is currently pointing to B object. Okay, so temp dot next means next of B object is 3000. So this expression evaluated to 3000 in our example, and that 3000 should assign to what? So next of node means the object which is being pointed by node. For that next we have to assign 3000. Okay, so node dot next. So node is pointing to E object. If I show you, here it is. Okay, so node is pointing to E object, and node dot next is this one. So inside this we should have what value? 3000, that was evaluated from this expression. So node dot next will have the value 3000. This value will be overridden, and it will be having value 3000. Okay, so if I draw the diagram, this next eventually have the address of object C. So it can, it will start pointing to C object like this. Okay, so this is how it will point. And then again in the next line we are saying whatever the address that we have in the node, please assign to the next. Which next? So the one which is being pointed by temp reference variable. temp is currently pointing to B object. Okay, so next of B object should have value node, whatever is in the node. So node is having 5,000. So this 5,000 should assign to next of which object? B object. Okay, so next of B object is here, and inside that we should have 5,000. So we will override this, and this will be 5,000. Okay, so if I draw diagram, you might have understood that now this arrow will no longer will be valid, and since the next of B object is having 5,000, and if you see, so 5,000 is the address of which object? E object, right? So this one will be pointing to E object. Okay, so this is how it will be. And then condition is break, means since the record has been added, break will make the control out of while loop. Okay, so it will escape now while loop now, and it will come here. Okay, if I press F10, you can see, and that time position was okay. So you see here position is equal to 1, and here it will check position is not equal to 1, condition will be false. This way it will return the head. Okay, so basically we are able to add the record at the position, and then display basically will work, which will show the record, and you see 51 got added, even it got added here also. And we didn't delete. So what is happening, once the method gets completed, it will delete all the temporary variable, like temp will get deleted. Okay, and anything else that we created, that will means this node also. Okay, so we can delete that also, then you will not get confused. So this node will get deleted. Temp was also created as a temporarily from the method itself. So here it will be. And now if you see, after executing this method, insert at particular position, this is how the new basically linked list we have, where A is pointing to B, B is pointing to E. You can see that this E object got inserted between B and C. Now B and C is not directly connected with each other. B is pointing to E object and E is pointing to C object, means this element got inserted. So this is how it works if you have to insert at particular position. Likewise, okay, we have another method that we implemented, like remove first node. Okay, so we have to delete the first node. So how we can do? Simply we will call, I will comment this line, remove the breakpoint, remove first node. So if you theoretically, if we discuss about this, we have to remove the first node. So this is very easy. How? Basically head is pointing to B object. Okay, so now we will tell head should point to whoever, suppose E is the first element now. Okay, basically if you see, let it be here itself. Okay, so now the second object will be 51, assume. So now rather than print pointing towards the B object, we will say head point to the second object. So when head will start pointing to second object called E object, there will be no reference variable for this B object. Currently, head is the only reference variable which is pointing to this object. That's why it is in memory. There is a rule with the garbage collection that if an object has no reference variable, then automatically that will be removed by garbage collector. Okay, so garbage collector will collect it out from the memory. We just have to shift this pointer, head pointer, towards the second element. This is what we will do. So if you see in this one, remove the first node, same thing we will be doing. I will execute and I will quickly show you. So control will come here. Okay, it is, I think it got stuck. Okay, I'm not sure. So let me save it. I will put the breakpoint here. I will try to run. Yeah, it came. So now if you see the same logic we have, like this dot head is equal to null, this we are checking whether, see, if head is not pointing to anything, it means it is empty. Okay, so just to check the empty, but definitely head is not null, we have some value inside that. So linked list is not empty, some datas are there in the linked list, so this will be false. Now what we are doing, if you see, this dot head dot next, head is pointing to b object, if you see. So next of b object, this expression evaluate to b next of b object, because head currently is pointing to b. So next of b object having 5000. Okay, so this expression evaluated to 5000, and that 5000 will be assigned to this dot head, means inside the head only. So what will happen here, the head will have, overridden their value to next value, that is 5000. Okay, so now you see, this pointer will be, this arrow will be deleted, no need to be keep this. Anyway, this arrow is for our understanding purpose only, so that we can easily identify this one is pointing to which. Now head, if you see, is pointing to the object whose address basically is 5000. So you can see clearly, e object is something which has the address of 5000, means head will be pointing to this e object. Okay, now if you see, b object is there in the memory, but there is no reference variable which is pointing to this b object. So now this will automatically will be deallocated by the garbage collector. Okay, we don't have to worry about that. And now our, so garbage collector will be removing that from the memory. So new linked list that we will have is, a head is pointing to e, then c, then d, so automatically b got deleted. Okay, if I say, and it is returning the head address. Okay, so if I show you, you can see here कि now 51 and 30 and 70 is there. So you see here 51, 30 and 70, and the same thing we are getting on here also. Okay, because the first element 56 was deleted. Okay, so remove, this way basically we remove the node from the, or you can say first node from the linked list. Likewise, if we have to delete, if we have to delete the last element, so last node, in that case how we can do delete, let's comment this one, we will not be deleting the first this time, and we'll say remove the last node. Okay, so how last node will work, let's see their implementation also. So basically, we'll execute it in debug mode, and we will trace this also. Okay, let me run it again. Yep, it came here. And then if you see, so it will also be executing like while block. Okay, until we get something null. So here, if head is equal to null, if you see again, this time I have deleted this one. Okay, so you can assume in this execution 51 got inserted again. So our pointer, or what I can do, let me delete this. Okay, I will again, I will stop this. I will say remove first node, let it be as it is. So automatically this method will be deleting the 56. So now we will have 30, no, 51 will be added, then 30, then 70. So we can run this. Okay, and then head is equal to null, no, head will be pointing to e object which has value 51. Okay, so this one be null. Head dot next is equal to null, no, head is pointing to e, and e dot next means next of e object is also not null, it is 3000. Okay, so that will be again false, so it will skip that. Now we are creating one reference variable, local variable, new node, and inside that we are storing the address of head. So currently head is having 5000. So new node will be created here, new node equal to 5000, and you might have understood 5000 again is the address of e object. So means this new node will also be pointing to e object. Okay, And then while new node dot next, this might seems little complex, but you have to recognize it how basically we can read. So next, of which next new node. Let's start reading from this. So new node currently is pointing towards e object. Okay, you see, new node is pointing to e object, and inside e object next variable is there. So the value present inside next of e object is 3000. Means till here the expression will be evaluated to 3000 dot. You can consider this dot means go to the address which has been evaluated till here, which is nothing but 3000. So if you see, 3000 is nothing but is the address of c object. Okay, and then from c object find the value present inside the next. Okay, so in the c next has 4000. Okay, so this entire expression evaluated to 4000 is not equal to null. Condition became true. Okay, so since condition became true, it will go inside the while block. Now new node equal to new node dot next means next of which object, the object which is being pointed by new node. So new node currently is pointing to e object, so next of e object which is having 3000. So this one will be evaluated to 3000. 3000 will assign to new node. Okay, so the new value of new node will be 3000. Okay, so we can mark it here 3000, and of course this arrow now will no longer be valid. So new node will be pointing to now c object. Okay, here you can see c new node pointing to c object. Then again while block will check, and new node dot next again read the same way. Next, the value present in the next variable. Whose next? The one which is the object which is being pointed by new node. New node is pointing to c object, so next of c object which is 4000. So this one will be evaluated to 4000. Then dot means again you can say go to 4000. Okay, so the go to the object whose address is 4000. So address of 4000 is d object. Okay, so now for d object read the value present inside this next. Okay, so if you see the next of d object is null. Okay, it means this condition here, this one evaluated to null. Okay, and this one is null. So null is not equal to null. Condition became false. Okay. Since the condition became false, it will escape the while block. Now what we are saying, new node dot next equal to null. Assign the null to next. Whose next? The object which is pointed by new node. New node is pointing to C object. Okay, so next of C object should have what value? Null value now. Okay. So if you see, this value 4000 will be overridden and the new value will be null. If it is null, of course, this arrow will be no longer valid. So this one will be removed. Okay, and again the same logic will apply. Now see, there is no reference variable of this d object. This become orphan. Okay, this object is now no longer being pointed by any reference variable. Hence this object will also be garbage collected by the garbage collector. We don't have to worry. In here in linked list, in order to remove the element, you just have to make that object dereference, means remove their reference variable, and automatically they should be treated like that has been removed, because garbage collector will come and that will be removed from the memory. So you see, d was the last element and that has also been removed, and then it will return basically the address of the head object. Okay, whatever the value present inside the head, so that we are just returning for simplicity. And now element has been removed. Display will show you that the element that was added in last was 70. You see here, the one that has the value 70 will no longer show in your console window. So here you see, we are getting 51, 30, but 70 is not showing. Okay, 56 was already deleted by this method, remove first node. Okay, and this 70 got deleted by remove last node. This way it removes. Okay, now we have one more method called search. So how this search will work, let's see. Okay, this time we will okay, so we have now the value 35. We will say I want to search what, 30 only, for example, or maybe 51 that we inserted. So we can remove the 35 and we want to check 51. Okay, so we will put breakpoint here and then we will run. So how search will work, we can see. Okay, let me run it again. So in this you can see the search value is 51. Okay, and now here again one different temporary variable will be created. So that time basically I didn't deleted this, so they are the local variable that will get deleted. Okay, I hope now you understood this. So this reference variable will be deleted automatically. So the new linked list that we have is A, E, C. Okay. Currently we will have the D, but you know when this method remove last element will execute, that will eventually delete D also. Currently we have, okay, but that will be deleted by remove. So we are searching for 51. So let's see now how it will work. So one temp variable will be created which have the value head, whatever is present inside the head, which is 5000. So again temp variable got created with value 5000. You see, basically 5000 is nothing but the address of e object. So this temp will point to e object. Then temp is not equal to null. You see, value is true because temp is having some values, right? So this is not null and this condition will be true. It will come inside that, then it will check temp dot data is equal to value. So you see the data property we are reading, whose object data we are reading. Again the same thing, you have to identify the temp. So you check temp is currently pointing to which object. Temp is currently pointing to e object, means data of e object. So data of e object is 51, so this one evaluated to 51, and the element that we want is to search is also 51. Condition will be true, it will go inside the if block, it will show it will print this message given value is present. And since we found the element, it doesn't make sense to continue the while block, hence we wrote return. Okay, so it will not execute anymore. Okay, and we have found the element. Okay, we will continue now, and you can see the message given value 51 is present in linked list. Okay, so this way basically what are all the features that we want to implement, we can implement. Okay, like currently we have implemented our own way of inserting the record at particular position, how we can remove from the first position, how we can remove from the last position. Likewise we also implemented the search. Okay, so this way we can have multiple implementations, whatever the implementation that we want for the linked list we can implement by our own. So that's it.